In lesson 9.1, we work on relating tenths and decimals. So we have a problem here. Ty is reading a book about metamorphic rocks. He has read 7/10 of the book. What decimal describes the part of the book Ty has read? So a decimal is a number with one or more digits to the right of the decimal point. You can write tenths and hundredths as fractions or as decimals. So the first way that they want us to try to solve this problem is to use a model and a place value chart. So for the fraction, they want us to shade 7/10 of the model. So I'm going to shade 7 pieces of it. So our model is now shaded to show 7/10. If we read the fraction 7/10 and we write it out in words, it's just going to simply say 7/10. In a decimal form, so they want us to write 7/10 in a decimal form. So since we have no whole number here, our ones place is going to be a 0 because anything to the left of the decimal is going to be a whole number. Anything to the right of the decimal is going to be a fraction. So we have tenths, so we're only going to be focusing on this first box, and we have 7/10. So it'd be 0.7. And then if we were to read it and then write it out in words, we would write 7/10. Another way that they would like us to solve this problem is to use a number line. So we have to label the number line with the decimals that are equivalent to the fractions and locate the point 7/10. So if we have 0/10 is equal to 0.0 and 1/10 is equal to 0.1, 2/10 is equal to 0.2, then 3/10 would be equal to 0.3, 4/10 would be equal to 0.4, 5/10 equal to 0.5, 6/10 equal to 0.6, 7/10 equal to 0.7, 8/10 is equal to 0.8, and 9/10 is equal to 0.9. And then we have 10/10 here, which we know is equal to 1. In decimal form, we write that as 1.0. So it wants us to focus on the fraction 7/10, since this was the fraction in the original problem. And it wants us to write the decimal form of 7/10, which would be 0.7, which names the same amount as 7/10. So Ty read 0.7, or 7/10 of the book. Our next problem is going to deal with a mixed number instead of a regular fraction. So in this problem, it says Tara rode her bicycle 1 6/10 miles. What decimal describes how far she rode her bicycle? So we've already written this fraction as a decimal. We also can write mixed numbers as a decimal as well. So if we're going to talk about shading 1 6/10 in this model, we would have to shade the whole first box of the model because we have one whole. And then since we have 6/10, we just have to shade 6 parts of the second box in the model to show 6/10. If we were going to write this fraction or this mixed number, we would write 1 6/10. And if we were going to read it and write it in words, we would write 1 6/10. Decimal form, so we have 1 6/10 as one whole and 6/10. So as I said before, we write whole numbers to the left of the decimal. So since we have one whole, we are going to put 1 in the ones place. And then we are focusing on tenths, and we have 6/10. So our 1 6/10 mixed number as a decimal can be written as 1.6. And if we're going to read this, we would also read it and write it as 1 6/10. The decimal point acts as an and, so we say our whole number and then what we have left over, or the fraction, the number of tenths, hundredths, or thousands as we move on later in to 5th grade. So they also want us to use a number line down here. So if we have 1 0/10, which is the same as 1.0, 1 1/10 would be the same as 1.1, 1 2/10 the same as 1.2, 1 3/10 is the same as 1.3. Now for a mixed number that comes after 1 3/10, we would write 1 4/10, which is equal to 1.4. After 1 4/10 comes 1 5/10, which is equal to 1.5. Then we have 1 6/10, which is equal to 1.6, followed by 1 7/10, which is equal to 1.7. 1 8/10 is equal to 1.8, and 1 9/10 is equal to 1.9, followed by 2 0/10, which is equal to 2.0. So they wanted us to focus on the fraction 1 6/10 and write that as a decimal. So 1.6 names the same amount as 1 6/10, so Tara rode her bicycle 1.6 miles. And as we move on for extra practice, we have our directions here are to write the 5/10 as a fraction and as a decimal. So if we're going to write 5/10 as a fraction, we first can shade this model to show 5/10, and then write the fraction 5/10. And then as a decimal, we can use this place value chart to help us. So in 5/10, we know that we have no whole numbers, so that is a 0. And then we have 5/10. So as a decimal, 5/10 is written as 0.5. In number 2, we are supposed to write the fraction or mixed number and the decimal shown by the model. So since we have 2 whole boxes shaded, our whole number is going to be 2. And then we have 2/10 of this third box shaded. So we have a mixed number of 2 2/10. And if we were to write 2 2/10 as a decimal, we would write 2.2. And over here we are focusing on number 3 on this point in the number line. So if we have 5/10 here, then we know that this line represents 6/10, the next one represents 7/10, and the one that we are focusing on then represents 8/10, and writing 8/10 as a decimal would be 0.8. In number 4, we are supposed to write the fraction or the mixed number in the decimal shown by the model once again. So in number 4, we have 1, 2, 3, 4 out of 10 shaded, so 4/10. And to write 4/10 as a decimal, 0.4. Number 5, they want us to focus on this point right here. So if we have 1 0/10 here, this would be 1 1/10. So 1 1/10 is our mixed number. And our decimal for that would be 1.1. Number 6, we have 1 whole and 9/10 shaded of the second block. So our decimal point would be 1.9. And for number 7, they want us to focus on this point right here. So if we know that this one next to it is 3 5/10, we can conclude that the one before it would be 3 4/10. So our mixed number is 3 4/10, and our decimal would be 3.4. And down here, number 8 through 11, it wants us to write the fraction or mixed number just as a decimal. So 5 9/10, we have 5 as our whole number, our decimal, and then we have 9/10. 9/10 is the place right to the right of the decimal. If we have 1/10, we have 0 wholes and 1/10. 7/10 would be 0 wholes and 7/10. And 8 9/10 would be 8 wholes and 9/10. And a couple more problems here. So on number 18, it wants us to look at this graph or this chart over here, and it wants to know what part of the rocks listed in the table are metamorphic. We need to write our answer as a fraction and as a decimal. So if we count the number of rocks we have here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we know that we have 10 of them, and it wants to know what fraction of these is metamorphic. So as you can see, we have 2 that are metamorphic. So our answer for the fraction would be 2/10, because 2 out of 10 are metamorphic. And if we write 2/10 as a decimal, 0.2. And then last but not least, number 21 says select a number shown by the model. We have to mark all that apply. So I'm going to problem solve to myself how to figure out how many are here. So if we have 1 and 7/10, I know that 1 is the one whole with 7 out of 10 left over. Well, here I have one whole and there are 7 pieces shaded here. So 1 and 7/10 does represent this number. 70/10. In order for this to be correct, I know that I have to have 70 parts shaded in blocks of 10. I do not have 70 parts shaded, so this one cannot be shown by this number. 1.7. So I know I have one whole, and then I have 7/10 here, so 1.7 does represent this model. For the number 7, this is just a whole number. So since we don't have 7 whole boxes with every piece shaded, 7 cannot be the answer. And 0.7. So the point part, the 0.7 part, the 7/10 part is correct, but here they have a 0. So I would not be able to have one whole if I would click or choose this answer. So this one is incorrect. And then 17/10. This fraction is telling me that there are 17 pieces shaded and each part is broken up into 10 equal parts. So I have 10 here and I know that I have 7 here. 10 plus 7 is 17 and each of these are broken up into 10 equal parts. So 17/10 is shown in this model.